out or whatever these people do. I think we talked about this before, but maybe not. We haven't. We'll talk about it definitely today. And it's under probability. Probability. And under probability, we are talking about, boys and girls, two different types of probability. One of them is called experimental, and one of them is called theoretical. Experimental and theoretical. And what would be the difference between those two? Okay, theoretically speaking, okay, this is when you do the math by the numbers, whatever. Experimental is the probability that you come up, God bless you, when you actually do the experiment. Now there's some probability that can only be done experimentally. For example, Brady Sovereign shoots a basket or he's at the free throw line. The probability of him making a free throw, okay, there's no mathematical formula that will come up with that, right, Brady? I mean, you can't sit down and do the X's and O's. What you do know is that, let's say Brady is shot, I don't know, let's say he shot 20 free throws and he's made 11 of them, which might be a little high. Oh, okay. The probability of him making it is 11 over 20. Okay? That is his probability. You can't change it. And that is by doing an experiment. Okay, now there's some other things that you can do both experimental and theoretical, and we're actually going to do this here. For example, what is the probability if you have a dice? Where's my dice? If you have a dice, one is a die, right?
Yep.
If you have that thing, paste it in here, it's going to be absolutely ginormous. If you have a dice, and I asked you what the probability of rolling, Norquist, give me a number that's on your dice. 3. If I ask you the probability of rolling a 3, mathematically, what is the probability of rolling a 3? Well, how many numbers are on a cube? 6. And how many of them are 3s? Sides. There's only 1 3. So your probability is 1 out of 6 times, okay, you should get that 3. Now, experimentally, is that going to come up to be true? Well, we're actually going to test that little theory here. Here's what you're going to do. It won't take us very long. At each grouping of tables here, Ephraim and Ronnie, you guys are going to do this one. I'm going to give you a die. We're going to actually test this out. You are each going to roll it, I don't know, let's go 20 times. No, 20 times, that's a lot. Let's just go, you're each going to roll it 10 times. The other guy records how many times they get a 3 out of 20. You count for the other guy. All right? Wait till I get there. Write it down on your piece of paper. Charles, you and Kevin can do it. You can go by Charles there. All you're going to do is, so you're going to roll it. One of you is going to roll it 10 times. The other one's going to roll it 10 times. I want to know how many times. Wait, no, let's do it. Let's do this. You're going to roll it 12 times. Why am I using 12? Because 1 out of 6 times it should come up with 3. So, theoretically, you should get 2 3s when you roll it twice, or 12 times, right? So yeah, I want to see what it is. You each are going to roll it 12 times. Make this quick because we're digging into our time here. Each of you roll it 12 times. 12 times. One guy rolls, one guy records or counts for me. You don't have to write down the numbers, just write down how many times out of 12. Yeah, do 12 one and then 12 the other. Count how many times they roll it and how many threes they get. I only need to know how many threes out of 12. That's all you're recording. You don't have to record every number you roll. How many threes out of 12? Wait, come on. How many threes out of 12?
Okay, those last two.
I got 3 out of 14. I got 2
How many threes out of 12?
Wait.
Perfect. Half the time you got threes.
You only do it once per group.
You need to do it 12 times.
Oh.
When you each get 12 rolls, then bring me your dice so I don't have to worry about playing with it. It shouldn't take you very long. This is our experiment in probability. Then you keep your stats. You guys done? Leah and Ellie? Cross it here, I can catch it. Alright, now, here is what one must understand, okay? Because casinos and all those places that work on probability sort of things, they know, that in the end, odds are going to work out. The probability, the odds always kind of work out. Because Aiden threw in something there, he goes, out of 12 times, Aiden got 6 of them, okay? Which means if you went to the casino, he's going to hit it big. Okay, but the thing is, the more times, if Aiden keeps going over and over and over and over and over and over again, eventually those numbers are going to balance out to where they should be. So, and then let's take a look here. So, let's see, how many times, each table rolled it 24 times, right? 1, 2, 3, 4, 5, 6, 7. So there are 8 24s. Was there 8 different groups in here?
Yeah.
There should have been, right?
Oh, yeah.
So, let's see, 8 times that. We rolled it the number how many times? 32, 3, 16, 192 rolls, right? And if the theoretical probability works out of those 192 rolls, 1 out of 6 times, right, you should get a 3. So you divide that by 6, what do you get? 32. Okay, we should have ended up, after all the smoke clears, theoretically, 32 times. Now the thing is, when you look at each group, you might say, well, we only got 6. I might got 6, which is high, but some of you probably don't. Let us check and see what we ended up with. So, starting over there, Ellie, how many? Wait, are you guys doing it as a table? Or you doing each person? Let's do each person. So, Ellie, you got how many? How many threes did you get? 0. Good. Well, wait, Kevin, how many did you get?
4.
1, 2, 3, 4. Leah? 1. Chloe?
1.
1.
2.
2.
5.
Charles got 5. 1, 2, 3, 4, 5. Kate?
2.
Got 2.
4.
4. 1, 2, 3, 4. Leah? Or let me see, Lacey? 3. 1, 2, 3. You got 6 still? 1, 2, 3, 4, 5, 6. Sam? 1, 2, 3, 3, 4. Am I right? 32 already? Oh, that's gonna mess me up. Brennan? 3, 1, 2, 3. 3, 1, 2, 3. 2, and 2 for Brady, which gave us how many? 10, 20, 30, 40. 40 out of 192. Okay. Now, the thing, but the thing is you have to, did I get you guys?
No.
Oh, Ephraim, sorry.
I got one.
You got 1, Ronnie?
3.
3, 2, 3. So it'd be 44 out of that. Okay, and again, that number's a little ways off from that, but if you'd have just taken Aiden's, Aiden experimentally got 50%, or 6 out of 12, or he got half the time. But as you continue to do this more and more and more, if I had you do it 1,000,000 times, well, if I had you do it 3,000,000 times, I'll bet you get awful close to the number 1,000,000 out of 3,000,000. Is that, oh wait, no, I'm sorry. It'd have to be out of 6,000,000, you probably get close to that 1,000,000 times. Eventually, ladies and gentlemen, these two, theoretical and experimental, will close in on each other if you do it enough times. That's why the lottery works. That's why people go to casinos and, casinos stay in business. Because I could, if I was looking to make some serious cash, what I would say to Aiden is, Aiden, you give me $1. If you roll a 6, I'll give you $5. Okay? Now Aiden's going to say, well, hey, look, he spun 12 times, so he gave me $12, and he got 6 of those, and I had to pay him $5 each. I had to pay him $30, right? So he made $18. But I can tell you, the more that Aiden does it, and he thinks, well, yeah, and that's what people, usually when people go to the casino, they get lucky like that first time, which is the worst thing that could happen to you because you think that's what's going to happen every time. And then in the end, Aiden's going to maybe go the next whatever time, and he doesn't get any. And then he loses $12 and blah, 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 blah. So I hope you can kind of see that experimental and theoretical eventually will come together. But there are some things that you can't do theoretically. The book has a problem. Let's see, let me write it down here. If you look at your book, if you look at page 403, example letter B. Letter B says, Quinn runs a sandwich shop. Since she added the turkey melt to the menu, 36 out of 120 customers ordered the new sandwich. Ordered the new sandwich. Or sandwich. And then it asks you, what is the probability the next customer will order? The probability the next customer will order the turkey melt. Okay, well this is experimental probability because you got the data of a total of 120 sandwiches, 36 of them were turkey melts. So there is your probability. It just needs to be reduced. What number goes into that? 4, 9 over 30, 3 out of 10. The probability would be 3/10 that it's going to be a turkey melt. Again, that is simply based on, there's no mathematical formula that you can use to figure that out. You just have to take the data and you get the experiment that's done, and that gives you the probability. Do you see the difference between experimental and theoretical? Because that will come up on certain quizzes there. That's fun and exciting, isn't it? All right, for tomorrow. Oh, look at all the time here. We already did the quiz on the up and down thing. Let's see how far you get on lesson 59. Lesson 59.